Good day, welcome to Creative Vision Studio. Today I'm gonna show you how to do a procedural lightning. Okay, and this we are going to do in Houdini. So as you can see, uh, a procedural lightning takes time to create and it takes more creative energy. But what we are going to do is we are going to take it step by step, and this is the part one of the tutorial, in which I'm going to show you how to create a structure, as you can see here. So there's a concept we are creating, and this from Daniel Hogan from a VFS studio. Okay, so and at the end we are going to change this into a more beautiful and interesting concept. So without wasting much of the time, let's dive into how we start the structure or the basics of this procedural lightning. First of all, what I did here is creating a sphere. So I created a sphere. Let me turn this down for now. Okay. So I created a sphere and I changed the radius to 0.5 at the S, Y, and Z angle. Then I have to center it. Okay. So and the uniform scale is 0.82. So this center of a thing might I can see it's off the ground plane. Okay. So this all about it. Then I added a transform, which is not a big deal. Okay, so I just use it to translate the sphere when I'm testing the procedural lightning. So in which you can still control this from the sphere. Okay, you can still control this from the sphere, the position of the sphere here, but I prefer using a transform node to do that. So after that I added a facet node, and the function of the facet node is I added it to pre-compute the normals. Okay, I added it to pre-compute the normals, so that's what I added it for. And if you're going to check our normals, okay, now when we pre-compute the normals, this is how it's looking before, so the normals end looking good. So we just have to pre-compute this so that every axis of the normal will face the right direction. So that is that. Okay, what I did is to add a scatter node, and as you can see, the point I set the first total count to 50, and our numbers are all facing the right direction. So before I added this attribute node, I also have to raise this to this grade, and the first thing I did is to create a grid, and in which I can see that the number of this grid is not cool at all. Okay, so let me see what I can add to. I see add a facet node to this. Then let's also pre-compute the normals and see. Okay. Now pre-compute the normals. They're all looking good. Okay. So before it wasn't. Okay. So now what we are going to do at this point is to also create a cube. Let me zoom this back, and also this cube I have to set the size and position into this, and I have to also set the rotation. Okay, so but all I did was to merge them together. This cube is now serving as a wall, while this grid is now serving as a base ground, okay, for this lightning to hit the wall. So that's the little concept about this, just to form the structure of this lightning. So After that, I added a array node. So what we are doing is I connected the scatter to the array point or primitive input. Then I connected the collision primitives, which is our floor and our wall, to the collision primitive input. So now I set the method to projection rays, which is better for me. Okay, then I set the ray tolerance to 0.01. okay, so that's what I did there. So as you can see my settings, so I did not play with the jitter scale or any other thing. Then after that, I have to merge this. I have to create a merge node, and this merge node, I wrote a simple attribute vex expression. And what's the vex expression all about? Well, we need the point number, the particle ID of the point number. So in which I just use an integer and I create an attribute of particle ID, okay, and I assigned it to the point number. Okay, so created an attribute of particle ID and assigned it to the point number. Now we'll be able to control the points, and this will help us in a long way in creating this lightning. So I have to input that particle ID to the merge node and connect it to the ray also, in which is connected to the collision primitive, and I merge them both. So that's what we're having now. And if we do this, we'll find out that the points, they are all rayed, and the particle ID in which we assign to the point number, this will help us identify each primitive. If I should turn on our visualizer, if I should turn on our visualizer and also our point number, I have to add good. Now you find out that this each of these particles now have a different number, right? So now we want this, as it is showing each attribute, each point ID should be rayed onto these collision primitives, and this is what we are going to do. And this is the whole purpose of creating this point attribute, to help us manipulate these points. So let me turn this off. Now the next thing we are going to do is to create a ray hit group. So this ray hit group is going to take off points that are not raying over this collision primitives, and this what we are going to do is to create a ray hit group, and you just have to create this point group and name it that. Now we have to bring it over to the blast. We have to bring the blast node, and what we want to delete is this ray hit group, that is extra points that are not hitting or they are not raying over the collision primitives. Then we have to fix in the add node, okay, and we choose the attribute name, which is the PID. Now this add node now will help us connect based on the particle ID we created, right? So it will help us connect a line to each of the point that is rayed to this geometry. So because this is the whole point of creating it, and each particle numbers, we find a number that is relative to him, same number that is relative to him, that is being read on this geometry. So and this will help us create a line. So and you can set this by attribute, okay? So you will set it to attribute at this place, and then you call in your attribute, which is the particle number, the particle ID, which is being assigned to the particle number of this scatter. Now the next thing we have to do is to add a facet node. and this time we are going to remove extra point that we are seeing on our viewport that is not on use. Okay, so now this will help us to, if we click remove degenerated, okay, so it is going to remove those points out, and these are all points that are not extra points that are not in use. Okay, so now we are now left with the point that is being totally red on this collision geometry. So for example, to totally visualize this, we have to connect the original geometry. So you can see drawing this from the transform and also drawing this from this mesh, and we'll merge them together. And when we add a resample node to add more points to this line, so that the reason why we are resampling this is we can be able to break this line and create a noise that moves in electricity kind of vibe. So that's what we are going to do. So, but as you can see now, we have our everything is fully set. And sorry, I did not show you how this will work because I'm carried away by another thing. So if I should use this transform node right now, and let me just zoom back, and I use this transform node to move this from each axis, you can see they're all snapping. Okay, and every move we make, it finds a new position and snap to. This is the function of the rain node and every other point we created. So as you can see now, the lightning is moving, and this is procedural. So, and I'm going to show you why this is so sweet and so cool. Now you can choose to decrease the number of the electric lightning here, or you can choose to increase it. So if you increase more, the more it search for more points and connects to. So, and if you decrease it, the less it search for more points also and out to itself. So we add the resample node here. So I'll just set the level of details to 1 and the length to 0.2. Okay, I think that's all for now. So the last thing I did is to just like I told you, this is the part 1 of this tutorial. So I created a core view attribute, and the whole point is to be able to manipulate these points and a line that you have created. So to visualize this, you have to use the core view attribute. Okay, so we started the core view attribute and use infrared to visualize this. So now, as you can see, this pure gradient from this. Let me turn off the points. Now that's what we have. Okay, now our core view attribute is in play, and you can see how this ramps from the start to the end. So in our next tutorial, which is the part 2, I'm going to show you how to do this and how to break it up and create something not something that looks like lightning, and create a realistic lightning. Okay, I'll see you guys in the part 2 of this tutorial, and please don't forget to like, share, subscribe, and go watch our short movie Clash of Power. See you next time. Bye.